Well, good afternoon from Washington, D.C. I'm Landon Darrant, Senior Director of the Atlantic Council Global Energy Center, and I'm really excited today to be joined by Tim Holt, Labor Director and member of the Executive Board at Siemens Energy, for an insightful conversation on transmission of all things, energy space, hot topics that I know will be highly insightful and a great conversation. You know, over the past few years, we've faced a series of economic and geopolitical shocks that have kind of really defined the energy sector, but there's room for optimism. We've watched the cost of renewable energy precipitously decline. We've seen an uptick in the adoption of electric vehicles, and certainly decarbonization technologies are accelerating as well. There are roadblocks, there are challenges. We want to get into those today with you, Tim. Really excited to do that, but particularly on transmission and manufacturing, because those are issues that have emerged as foundational. Maybe they haven't emerged. We've known they're foundational to the energy transition, and we need to be able to unpack that and know how to move that issue set forward in a really expeditious way if we're going to meet our energy transition goals. Before I jump in with you, a couple housekeeping issues. We welcome questions from the audience through this session. For those joining online, please submit questions to, and this is new, please submit questions to askac.org, askac.org. I will be taking questions right here from the audience and really look forward to that. So Tim, welcome. Really glad to have you here.
Thanks that you have me back here.
Yes. So, you know, before we jump in a deep dive on the components of transmission here, I actually think for the, broad audience, and for the neophytes that are out there, maybe you can provide a little bit of perspective of when we talk about transmission from a perspective of Siemens Energy. What are you thinking about? What technologies are we talking about? And then we'll jump into some of the policy considerations.
Okay. So when we talk about transmission from a Siemens Energy perspective, for us, transmission is the highway for the electrons. It's how do we move the power from the generation source to where it's needed. High voltage levels, we talk about transformers, we talk about substations, switchgear, we talk about these HVDC lines, we talk about synchronous condensers, FACTS to keep the grid stable. That's all what we do as Siemens Energy. So basically, really, how do we move electrons from A to B that people can use them?
So I think the audience can confidently know that we can't undergo this energy transition without that kind of technology. We got to get the power to end users, clean power. And when it comes to facilitating the energy transition and thinking about transmission, what challenges do you think are the most persistent issues that we need to tackle? And where do you see opportunities as well?
Yeah, now it's a good question. And I think for a long time we always talked about energy transition predominantly focused on generation, renewable generation. We talked about wind, onshore, offshore. We talked about solar. We rarely talked about what does it take to really make this happen and move the electrons. And I think that's the important part. We always believe there is more investment needed in the grid. But for a long time, the grid was, I would call it, elastic enough to take that renewable power and move it. But with that massive build out that we now see across the globe, predominantly also in Europe and the US, it comes to its limits. And now we're really at the inflection point where we need to look, what does it take to really build that efficient grid that will enable us to make that transition to net zero? And for me, there are three components to look at it, that we see that are kind of slowing us down now. The first one is, how do you look at a more centralistic planning approach? Right now, especially in the US with the different regions, everybody does a little. But at the end, energy is very holistic. Where the wind is blowing, where the sun is shining, where you have enough land to build these generations, that's not necessarily where you need the power. It's also not the region always where you need the power, so you need to bring it across different FERC regions. So how do you look at a more holistic planning over the next 10, 15, 20 years? What needs to get built where in terms of transmission? The second, of course, is once you know where you need to build it, how do you make sure you do it in the most efficient way? And there, especially permitting is a big issue. Certainty on you start, what you can do and how long it takes until you can actually start putting a shovel in the ground. And then the third element, equally important for the industry, especially given the huge demand that we've seen over the last 2-3 years, the increase, and we're updating our market modeling almost every 3 months now in order to anticipate what's coming, is more standardization of the industry. I mean, we have already started that over in Europe when we do the grid access, the offshore platforms. We're standardizing around one design, 2 gigawatt, 525 kV, for example. But we need more of that in order to really do that build out in the most efficient manner in terms of time, but also cost.
Yeah, well, I really kind of want to unpack these one by one a little bit more. The U.S. grid in particular is highly fragmentized, right? It's not, we don't have a monolith system. We have really 3 different energy systems, and even those are further broken down by regions and subregions. So when you talk about central planning and you think about a much more holistic view for the power sector, what do you think is going to enable that and incentivize policymakers to pursue that, in the quickest manner?
Ooh, that's a really tough question, and I think it's when you look at it, I think there's different requirements. Of course, every region has to ensure they have the power growth. They can connect the new consumers, the factories that come online, etc. And make sure who is in the region gets a secure power supply. On the other hand, we also know, with the build out, and my assumption is, driven also by the IRA and the build out on wind and solar, we're going to have much more load being built in areas where there is not the demand. So you need to move it across regions, and that's, I think, where it gets a bit tricky. So what's the incentive? I mean, you have it here, but you need to bring it to a different region. And how do we make sure that there's a common interest on both sides? And in the past, we built these point-to-point interconnectors, HVDC. But also, if we want to build from an engineering perspective, the most efficient system, you need to have enough connection points to do that. It probably requires the regions to come together and to some degree also compromise to create that optimal system, because you can have, as you said, 3 suboptimal systems, or you can have one big optimal system. And I think here lies a bit the complexity that's going to happen. How do you fine-tune the different knobs in order to build that system?
Well, ultimately, DC is a city of compromise. It may come at a very arduous pace and a lot of contentious topics. But to get things moving forward, we have to find compromise. That goes to your second point, permitting.
Yeah.
Can we talk a little bit about the business case and why permitting is so critical for transmission?
Yeah, as you know, a lot of the projects are multi-year projects, and so certainty how long it will take until you have all the necessary permits to put the shovel in the ground and start digging and actually building is really important. And we as Siemens Energy, we work with one customer who actually worked 18 years on his permitting until he is now finally ready to start the project. And I think it takes a lot of vision and belief that this is the right thing to do, to really have the confidence over 18 years to stick to it. But with this huge demand that we see for the build out of the grid, that's coming. We know it's coming. And then you have in between the permitting that creates the uncertainty. When are we actually ready to do it?
Sure.
That makes it really hard, both for us as technology and equipment providers, for our customers who are, of course, they need to connect, solar parks, wind farms, but also large factories that are in the queue. And in between, you have the permitting, the big unknown. How long is it until we actually get the project done and have the connection and have the line built? And I think that for us all in the industry is very frustrating because we know what needs to get done. We just don't know when it gets done. And I think that's where we really need to work on. I think, don't get me wrong, the permitting needs to be, or the process, the time needs to be appropriate. I mean, as you know, there's various aspects that need to be taken into account. But at the same time, there needs to be a certainty in terms of timeline. Here's when I put the application in, here's when I get my permit. And I think that fine balance needs to be there. But I think we can all agree there's probably some room for improvement to shorten the process overall.
It does feel like it's on the horizon.
Yeah.
Right? It feels like we're getting there. I want to take the conversation on standardization in a little bit of a different direction here, which is looking at the transatlantic partnership, because standardization is an issue that is multinational. It is certainly a transatlantic issue. It's being thought of in Brussels, in Berlin, and other capitals. How should we be conceptualizing standardization in that framework? Is this a space for example, the U.S.-EU Energy Council to be collaborating to find solutions and give even further business certainty to technologies necessary for the energy transition?
Yeah, definitely. And why are we talking about standardization, or what's the big driver? I think there's two drivers. One, we see this unprecedented market demand, and we in the industry as suppliers are facing the issue. Delivery times are extending. I gave the example earlier, where we used to have 18 months, 24 months delivery times for certain products. We're now up to 40 months. So you see that crush, and it's we're expanding capacity, but it's slow. So in order to be also most efficient and deliver the equipment, I think that's important. The other one is cost. Right now, if we do a custom engineered approach every time we do one of those big HVDC lines, if we do the connection to the offshore wind farms, a lot of engineering hours goes in there, and that's another bottleneck that we don't have. The second one is, of course, it gets more expensive. If you can take the same solution, 80% reusable, and then adapt it to the specific application, also very important. And at the end, I mean, we have all seen, inflation, material price increases. I think standardization is a way how to counteract some of those increases we have seen. And at the end, we all want to make electricity cheaper for the consumer. And that only works if we really also look at how do we standardize across. And again, it's an international business. In some of the big projects, there's 3-4 suppliers out there. So it's not just the US has their own standard, Europe has their own standard, other parts of the world have their standard. I think working and harmonizing to a large degree will help really drive both cost and time.
So, I think to put a finer point on this, when thinking about standardization, it sounds like we really need champions out there. And is this a place where we can talk about public-private partnership and collaboration? I know industry's already doing a lot. Siemens Energy is already doing a lot to drive standardization as probably a necessity.
Yeah.
What's your perspective on how we can have collaboration in that space?
I think it's already happening. And let's take a step back. Historically, every TSO, transmission system operator, every utility had their own standard. And the market, there were enough suppliers there, so the industry could entertain customization. I think what we've seen now between our customers and us, it's already happening. It's happening in pockets. We've seen it in Germany, other European countries following. US, not so much yet, I have to say. But also in terms of from the regulatory side, it would be a tremendous help to all of us. It's happening on certain national levels, but what you just described, the transatlantic, EU, within the EU, and then transatlantic would be a big help.
Tim, we're doing something right because I'm getting questions from the audience, and just to remind those that are viewing online, if you have a question, ask us on askac.org, askac.org. I'm going to go to one question here from Will in our audience, talking about the IRA, hot topic in Washington, D.C. We're almost 1 year on now from its launch. and clearly has had a transformative impact both in the landscape of the U.S. energy system, or will, but I mean in terms of the policy space, also reverberated quite loudly globally. We're talking about transmission today.
Yeah.
IRA does a lot on the supply side, brings a lot of money to bear. What's it doing for transmission, or what's it not doing for transmission, and how do we need to be thinking about that as we move forward?
Yeah. When I talked about IRA and how it's benefiting us at Siemens Energy, I always said there's the primary beneficiaries, wind, solar, hydrogen that we see in there, but all that needs transmission. And to be very honest, there's very little on transmission or on the massive transmission built out that's going to come with all the other generation support in the IRA. So it's not there. It's a necessity. I always called it a secondary effect. If IRA does what it does and we see that massive build out, transmission will follow. How is that getting funded? Not out of the IRA. Probably it's all of us with our electricity bills that will see that go up. It also doesn't do a lot in terms of incentivizing putting manufacturing into the U.S. on transmission equipment. Not as much as we've seen on other parts. But again, it creates opportunity for us. You don't necessarily need always an incentive to invest. If the market opportunity is there and the demand is there, of course, those are also thoughts we're now having, looking at the opportunities that will drive it, and then see what else is there in terms of incentives outside the IRA that we could benefit from potentially.
You mentioned it, manufacturing.
Yeah.
So we're not just talking about deployment of technologies, we're also talking about building them, whether domestically or internationally, thinking about the fabric around the supply chains.
Yeah.
A lot of discussion about bottlenecks. And you and I had a really fascinating conversation about this prior to the audience joining, and that I think is maybe not what I expected. And that has to do with manufacturing, not just from a hardware side, but maybe some of the other components. I don't want to spoil it. I want to give you the chance to build this out. But can you talk a little bit about the manufacturing and the bottleneck challenges that you're experiencing?
Yeah. So I think 2 points. One is, of course, all that increased demand that we've seen in the last 12, 18 months, really accelerating in the last 6 months. We've seen lead times go up. So our factories are really loaded. Delivery times have gone up from what I said earlier, 18, 24 months. Traditionally, some factories are loaded basically 3-4 years out. But if you look in terms of these large projects, what are the bottlenecks? And a typical project pipeline, 5-6 years. Even the increased delivery times are still acceptable and don't create the bottlenecks. Where we really see the bottlenecks is on the human capital side, on the qualified engineering, and it's an industry very specialized. For example, controls and protection. If you look at these large HVDC projects, people see a lot of equipment. They don't see how much programming actually goes into it, and it's custom programming, and those are special engineers, a lot of expertise, and that's where we've seen currently the biggest bottleneck. Just to give you an example, we have hired over 700 people last year alone. In that specific field, we have one experienced engineer, one engineer that has less than 18 months of experience. And you do these multi-billion-dollar projects. Of course, you don't put a team of engineers on it that have been working on it 18 months. So you need to get them through the project, with the experienced engineers. Once they have done a project, and as I said, we talk 3, 4, 5 years, then you can put them on a new one. And that kind of creates the bottleneck. And it's not just us and Siemens Energy having that need. Our competitors, similar recruiting efforts, our customers, of course, on the other side. So the whole industry sees this really huge demand, and the marketplace is really, pretty empty in terms of these resources.
Yeah, I was really surprised to hear about the human capital element of it. I guess it is somewhat intuitive, and I get we can make this a public service announcement for all the budding energy and climate professionals out there that maybe one of the best ways to make a dent in the energy transition is actually to become an engineer.
Yeah, electric engineer.
Electrical engineers. I'm sure the nuclear industry would like a couple more nuclear engineers. Plenty of space to go around. Another question from the audience here. It really comes down to finance, and they really want to build out. And the question from one of our online viewers is, noting the scale of this build out and how massive it is. What are we talking about when it comes to the cost? Where does the funding come from? Is this public? Is there enough of an incentive from the private side? You dabbled on it a little bit in terms of how we finance it through rate-based recovery. But just I think there's a question here of scale and what needs to be done on the finance side that maybe is missing.
Yeah, finance. Talking to our customers also, and I take both sides, the European and the U.S. side. There's enough money available on the funding side for transmission. And transmission is a very boring business, guaranteed rates of return in some countries on the transmission side. Very interesting for pension funds and so on. Not the greatest return on the money invested, but very stable. So very attractive. So, just in the interaction discussions I have with our customers, currently they don't see that not enough financing is there. Of course, I mean, we look at this massive build out. At one point, you might run into and saying, where's the money coming from? And then also on the other side, the opportunities are there. So even private developers have the risk appetite to say, I develop this HVDC line, I take the power out of the Midwest or Wyoming down into a load center, very attractive PPA, so the risk reward is also very attractive for the investor. So for now, not so much of an issue, but again, it's fast forward 2, 6, 9 years, and if you look what's needed, might get a bit tighter.
Well, at a moment where we have such a massive challenge, it's going to be enduring. It's something we're going to be addressing for decades to come. One facet of that that really reverberates here in Washington, D.C. is this idea of decoupling supply chains, particularly in the context of China. But I think, the IRA ruffled some feathers and across the Atlantic. How do we approach this, in particular in manufacturing? How do we take people who maybe want to see facilities built in their backyard and realize, climate is a global challenge. Yep. We need to be doing this in a way that is a global incentive. What's your framing from the Siemens perspective on that?
I mean, of course, there's different aspects to it. I mean, these large infrastructure projects, there's a lot of public tenders in there with certain requirements on local content. And of course, you have to see how do we fulfill this local content. I mean, one is, and I think it has to be clear, and take the wind industry as reference. If individual states put local content in, of course, not every manufacturer can build a factory in every state, because at the end, it's not just about the project, but it's also about the sustainability. We want to create jobs, but we also want to keep jobs. And I think it's no use, like we've seen in the wind industry, massive ramp up, and under the old PTC regime, then it came down, and you basically had to downsize the factory. So for us, it's much more, how do we size the investments in a way that is sustainable over the next 10, 20, 30 years versus, let's build a factory. There's lots of opportunity, but then 5, 10 years down the road, we need to ramp it down, and you price in that, you have to get a payback in that time. So for me, it's much more important to have this sustainability long-term view in terms of making the investments, but then also being able to sustain the investment, load the factories, and provide the jobs.
So Ben online here is honing in on one aspect that we kind of touched on a little bit, that deals with the build out and manufacturing as well, which is, you talk about the point of production to the point of demand. Yeah. A lot of people in between some of these projects that need the incentive and need to see the justification for putting large scale infrastructure across their backyards. What's your message to that community?
That's a hard one, and I always compare. If you have a wind farm, solar park, you put it in an area. There's some job. I mean, when you build it, but also when you operate it, there's some job creation with it. Wind turbines, there's the land lease, so farmers, landowners benefit from it. Transmission is a bit more tricky. You build these long overhead lines, and there's very little incentive for the in-betweens. I mean, that's a matter of fact. So the question is also, how does everybody benefit from it? Because clearly the job creation is on the sides. And it's not just an issue we have seen here in the US. All the countries that do this massive grid build out now struggle with it because nobody wants these overhead lines in their backyard. Some countries went on burying the cables, comes with cost and other challenges. But of course, it's something where we have to find a mechanism to make sure that we're able to build out the grid and making sure people feel they also benefit from it.
Could we use existing right-of-ways? I mean, is this something we can build on in particular on the rail, the highways?
Yeah, I think that's certainly, I mean, first of all, I think it depends. Existing right-of-ways, but are they the right-of-ways in terms of, is it where you want to build the transmission line? I think I think we're also seeing kind of a redrawing of the map because, you have the existing, but then you're kind of also redirecting power flows, right? Where the power is being built. I mean, the load centers are kind of the same, but where the power is coming from. So you have to also look how you do it. Interesting, I've seen some very interesting concepts where people say, how do we do this? There's concept using a old pipeline and putting the cable in the pipeline so you don't have to, build overhead lines. So people get really creative to say, this is a challenge. How do we overcome the challenge? And other creative ways how to put it, maybe next to the railroad, buried on the side. We have seen a couple of these concepts from developers, trying to see, okay, come up with a creative way to make this happen.
Well, that's great. So, well, speaking of creativity, at the Atlantic Council Global Energy Center, we look at innovation as a core component of the energy transition. And I think this is a part where there is strong public-private partnership, right? Governments need to be considering how they can incentivize innovation. Industry is innovating all the time. Can you talk a little bit both about the relationship between public policy and innovation, and also the innovations that you're seeing beginning to deploy that really are going to make a difference in this space?
Yeah. I think on the transmission distribution side, currently in the US, the focus, public-private partnerships is much more on the distribution side. That's where we see, we talked about microgrids, EV charging, rooftop solar, how do you build these small grids? There's quite a bit of activity on that side. On the transmission side, a bit less. I think it's also because it's an old industry, known technology. There isn't currently that much that needs to be done there in R&D technology investment. I think if you look ahead in the future and what is there to come, we see some pretty exciting things. One for sure is we talk a lot about HVDC connections. Those are point-to-point connections currently. There's a lot of discussion about a DC grid. So how do I make sure that I transport the electricity long distances, but have the possibility not just go from point A to point B, but use a mesh DC grid to transport it to various parts of the country, depending on load situation. So that's one of the exciting areas where we see technology going. A bit less is really how do we talk a lot about the net zero generation, but you can also talk about a net zero grid. How do I get SF6, the gas that's 20,000 times more harmful than CO2? How do I get it out of the switching and substitute it with technology? That's another exciting innovation we see. And then the last one is really all about automation and digitalization of the grid. And as you can imagine, you have a lot of wind, solar, fluctuations coming in, power quality. How do you make sure you keep the frequency stability? And there, how do you actually control and steer the grid and without interaction? It's almost like a self-driving car, right? I mean, that's kind of the goal that Tesla and others are working on. How can the car drive itself? and we're looking at it, how can the grid and all the subcomponents be, deliver enough data that it can basically run on its own and regulate itself.
Well, it's important to focus on that, because when we look at a company like Siemens, it's not just about the hardware, it's also about the digitalization and the software.
Yeah.
I guess, as we end here, I want to, one, give you a chance for closing remarks, but also just kind of a provocateur in the terms of AI, topics where we're cross-sectoral now, technology, AI, and that digitalization. Do you have any thoughts about that?
For me, I think it's, we talked about, how do you get enough qualified engineers? I think AI will be a great enabler to make this happen. If you look at this massive build out that will come, if we're continuing on this pathway to net zero, I don't think we have enough experienced engineers available to make it happen around the globe. And I think AI will play an important component in order to help us and help the engineers to be more efficient. I think the second part is really also all about what's the future for transmission. And I always, there's a statistic, what we invested in the grid in the US the last 150 years, the same amount we need to invest in the next 15 years, and that same amount in the following 50 years. So basically we only invested 1/3 of what's needed to build the grid, the future grid, and 2/3 get invested in the next 30 years. So it's a massive opportunity to demonstrate what we can do in infrastructure build out, what we can do in partnerships amongst all stakeholders, public-private partnerships, and it will just create a lot of job opportunities in the US, and I hope people get excited also about transmission.
Well, I think that's a great place to land this conversation, Tim. Tim Holt, Labor Director and Executive Board Member with Siemens Energy. We're so thankful to have you here today for a very vibrant conversation on transmission. Not always the most vibrant conversation, but I think we did a good job today. So thank you so much for joining us.
Okay, thank you, Len.
All right, see you soon.